In this lecture, we'll obtain the differential equation of a forced oscillator. Now, to know what a forced oscillator is, you should see the previous video and you will find the link in the description box to the playlist where all the videos of this chapter are uploaded. So just go through all the videos. Now, we'll obtain the differential equation for forced oscillator. So, what a forced oscillator is? See, in natural condition, when there are no resistive forces acting, then the oscillations were natural oscillations. But in practice, always resistive forces act, and therefore the oscillations will be damped, their amplitude will decrease. And because of that, we need to apply some external periodic force to maintain the amplitude of the oscillations. And such oscillations were forced oscillations. And we have to obtain the differential equation of forced oscillator. Okay. So suppose if the external periodic force applied is given by this equation, where F0 is the amplitude and omega d is the angular frequency of the external periodic force. So now we'll see total how many forces are acting on this oscillator. So see, total 3 forces act. First one will be the restoring force of the system. जो सिस्टम को अपने ओरिजिनल कंडीशन में रिस्टोर करने की कोशिश करता है वो फोर्स. दिस ऑल्सो वी हैव सीन अर्लियर. सो restoring forces minus ky. The resistive forces, because of the medium, because of friction, because of gravity, resistive or the damping force which acts on the system is minus bv. We know that velocity is change in position with respect to time. So instead of v, I can write dy by dt. Next is the external periodic force. The external periodic force we have supposed it is F0 sine omega d t. So total these 3 forces act on the system. Now if I want the resultant force acting on the system, what I have to do? I have to add all these 3 forces. So this is the resultant force, which is addition of all the 3 forces. Now from Newton's second law, instead of this F, I can substitute here m into a. All these terms I have written as it is. Now see what we are doing. We know that acceleration is double differentiation of position. आप position को एक बार differentiate करो with respect to time, then you will obtain velocity. आप velocity को differentiate करो with respect to time, then you will obtain acceleration. So acceleration is d square y by dt square. So we have substituted that value and we took these 2 terms on the other side of equal to, so they became positive. ये term मैंने पहले लिखा है और ये वाला term बाद में लिखा है. Now I'll divide whole equation by m. So यहाँ से m चला जाएगा, here in denominator m will come, here also in denominator m will come, and same thing here also. But now see, we know what is k by m and what is f by m. K by m is equal to omega square. जब हमने force law पढ़ा था for SHO, in that video you can check how this k by m is equals to omega square. So here we'll substitute omega square and here f upon m. See, f upon m will give me acceleration. So वो substitute कर देंगे. हमने external periodic force का जो amplitude था उसको f0 बोला था. So acceleration को भी हम a0 बोलेंगे. So this is the differential equation of forced oscillator. Or else I can say differential equation of forced oscillation with damping. Now see, initially the oscillator was oscillating with its natural frequency omega. But as and when we apply the external periodic force, the natural frequency will die out and the oscillator will oscillate with angular frequency of external periodic force, and angular frequency of external periodic force was omega d. So now the displacement of the natural displacement after the natural oscillations die out means the displacement after the angular frequency takes off will be this: y is equal to a sine omega dt plus phi, where this time t is measured from the moment we apply external periodic force. So this is the displacement after the application of external periodic force when the natural frequency will die out and the system oscillates with the external periodic force angular frequency. So this will be the displacement. Now, what will be the amplitude? You don't have to derive this equation, you simply have to remember the formula for this amplitude. This amplitude is given by this equation. It has relation between natural frequency and the frequency of the external driving force. ठीक है, एक्सटर्नल पीरियोडिक फोर्स को हम एक्सटर्नल ड्राइविंग फोर्स भी बोल सकते हैं, एंड दैट्स व्हाई वी आर राइटिंग हियर ओमेगा डी. दिस इज द एंगुलर फ्रीक्वेंसी ऑफ एक्सटर्नल ड्राइविंग फोर्स. Now, from this above equation, from this equation, we can say that the amplitude depends on angular frequency of external driving force. Formula में omega d है. So amplitude जो है वो external force जो हम लगाते हैं उसकी frequency कितनी है उस पर depend करता है. Now, as amplitude depends on the external periodic force frequency, we'll have certain relations between the driving frequency of external force and the natural frequency of the oscillations. So we'll consider two cases. First case is for small damping, where we'll consider that the frequency of the external periodic force is very far from the natural frequency, and the damping is small, means this B, damping coefficient, will be very small. This quantity, as the difference between these two will be very big, this quantity will be neglected with respect to this quantity. So this equation of amplitude now becomes like this. थोड़ा सा छोटा हो गया है क्योंकि ये damping वाला जो term है वो neglect हो गया है. So for small damping, amplitude will be like this. Now we'll consider case 2, where the natural frequency is approximately equal to the frequency of the driving force. If this is the case, then what happens? See, this is the formula for amplitude. Now, if these two are more or less similar, then this quantity will become 0. If this quantity becomes 0, then amplitude will become f0 upon this quantity. So, हमारा amplitude इस तरीके से change हो जाता है. यहाँ पर square है और यहाँ under root है. So, if I open, I'll get omega d b, just like what I did here also. So, these are the two cases for the relation between the driving frequency and the natural frequency of the oscillator. Now we'll understand one more concept, that is resonance. So see, resonance is a condition, it takes place when the natural frequency and the frequency of the external periodic force becomes equal. This is the natural frequency of the oscillating system. So when the natural frequency, that is omega d of the omega, natural frequency is omega of the oscillating system, when it becomes equal to the frequency of external periodic force, that is omega d, then what happens? Then the amplitude of the oscillation will become maximum, and when this condition takes place, we can say that our system is resonating. So in short, you have to remember that when natural frequency is equal to frequency of external periodic force, then resonance takes place because the amplitude becomes maximum. So from equation 1 which we have derived, we'll see what happens when we substitute omega is equals to omega d. So see, this is our equation 1. Here, if I substitute omega is equals to omega d, then this quantity becomes 0. So f0 upon 0 हो जाता है, and anything upon 0 will become infinite. So what I can say is amplitude is becoming infinite. So here just see, the amplitude becomes infinite, and this condition is known as resonance. Now we'll see one more condition, that if in equation 2, if damping becomes 0, then what happens? So this is our case 2. Here, if the damping becomes very less, okay, very less means negligible. If this becomes very less, तो ये क्वांटिटी कैसी हो जाएगी? 0 हो जाएगी. So again I will get f0 upon 0, and again I will get f0 upon 0 as infinity, means amplitude is equals to infinity. So इसको क्या हम रेजोनेंस बोल सकते हैं? यहाँ पर भी एम्पलीट्यूड मैक्सिमम तो हुआ है, बट एक्चुअली क्या हो जाता है, डैम्पिंग फोर्सेस कभी भी 0 नहीं हो सकते हैं. हमने देखा था कि डैम्पिंग फोर्सेस जो हैं, दे विल ऑलवेज बी प्रेजेंट सो ये चीज़ कभी हो ही नहीं सकती है। तो इस तरीके से आपका एम्पलीट्यूड मैक्सिमम कभी नहीं हो सकता है, बट हाँ ये कंडीशन हो सकती है, ठीक है। और इसके डिफरेंट एग्जाम्पल्स आपकी टेक्स्ट बुक में दिए हुए हैं, तो you can see those examples that when external periodic force frequency becomes equal to the natural frequency, then how amplitude becomes maximum, and that condition is known as resonance.